What's on the lines of it?
Why am I sitting here?
Yeah. Okay. So I've got the first job plan, of course, which is describe the processes involved with stellar formation. So the first process, essentially, or the first stage of the process, is it starts in a planetary nebula, well, not a planetary nebula, just in a nebula in general, which are often several light years across, and they're large clouds of gas in space that are made mostly of hydrogen. Inside this cloud, if the mass of the region of the cloud exceeds a number known as Jean's mass, where the internal pressure is not sufficient to counteract the gravitational force caused by the gas, the particles will begin to collapse into the center of that mass. So the second stage is the accretion of the protostar. So as the mass accumulates, of course, the gravity of the central point, which is accreting towards, begins to increase. So it accretes at a faster and faster rate. Now, as these particles rush in, they're losing their gravitational potential energy, and they're converting that energy to kinetic energy. And when they move, that kinetic energy then gets converted into thermal energy or infrared energy, which is radiated back outwards. So this energy that's getting radiated back outwards opposes the force of gravity inwards. So that slows down the rate of accretion, but not so much so to stop it from occurring. So the actual rate of accretion can take maybe hundreds of thousands of years for O-type stars to form supermassive stars, up towards tens of millions of years for a small star. And this forming protostar emits radiation mainly in the thermal spectrum or the infrared spectrum, and that's the way in which we detect them. The third stage is the ignition of the protostar. As the core will continue to collapse inwards under gravity and accrete mass until there is sufficient temperature and pressure within the core for thermonuclear fusion of hydrogen to helium to begin. This point at which the energy radiating outwards will be equal to the gravitational force inwards, and the star will reach equilibrium, and this will be a stable main sequence star. At the point of ignition, a solar wind is created because the energy of the star is massively increased, and it will blow away the layers of the nebula surrounding it, so the star will become visible. During the protostar phase, the star is often quite difficult to see because it's obscured by the nebula. Please, next one. Yeah, and because it's obscured by the nebula during formation, it can be quite difficult to see because this gas absorbs visible light. But protostars, as I said, emit mostly in the infrared, and this will pass through the gas cloud unimpeded. So, for example, NASA launches this space telescope in, I think it was the early 2000s, to observe these protostars, and since then many thousands have been documented throughout the galaxy, especially I believe in the large Magellanic Cloud and the small Magellanic Cloud, which are areas of high star formation. But yes, that is the process involved in stellar formation. Thank you.
So I think it would be good to actually put
Are you still recording?
yes, stellar formation. I'm just going to Google it.
Stellar formation. Love it.
We have that. Now time for ours. Yes.
So I just think you should have some respect for the actual sites of stellar formation and understand what Lachlan was talking about there. Not that they're quite pretty, but the idea that they're forming in nebulae, okay, and that there is a whole lot of dust and cloud there that's condensing and condensing and condensing. And so Lachlan used the word the star emits light. So we say that the star lights up, okay? When that inward pressure is big enough, the star lights up. The reason why the star lights up is because of that nuclear fusion reaction that starts. Okay? So until the star lights up, there's no nuclear fusion reaction.
But there is some visible light.
There is some visible light, yep, and that light is reflected. It's not making its own light.
It's generating
Heat?
infrared.
Yeah, infrared. Yeah. Okay. So just be aware of that, and just the thing that I'm kind of saying here is like that. The dust and gas is like our worst enemy in actually seeing things. Okay, just obscure this so poorly. All right. Who's next?